Hello everyone, welcome to section 4.5 in geometry. We are looking at conditions for congruent triangles. We are still not done. We've done side, angle, 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 side, but there's more. So let's find out what else there is. Okay, I have drawn two triangles on the board and labeled their sides, triangle ABC and triangle PQR. And AB is congruent to PQ, BC is congruent to QR, and AC is congruent to PR. If I have three sticks and they are all exactly the same length and three more all the same length, how many different triangles can I make out of those three sticks? Only one. So if I have all three sides of one triangle are congruent to all three sides of another triangle, then the two triangles are congruent. That is side, side, side congruence theorem, and you can just abbreviate it SSS. So that is our next theorem. It's helpful to have handy the different ways that you can show that triangles are congruent. We've learned side, side, side today. Side, angle, side, making sure the angle is included between those two sides. Angle, side, angle, making sure the side is included in between those two angles. And angle, angle, side, making sure that that side is the corresponding side. And then those are all you would need to show that the entire triangle is congruent to the other triangle. Side, side, angle, when the angle is not included, not in between the two sides, that does not work because you have a couple different options, a couple different triangles that can be made. So do not ever use side, side, angle. All that does is backwards spell a bad word, so don't even go there. Also angle, angle, angle. I can have three angles, but completely different sizes. So angle, angle, angle just shows that the triangles are the same shape, not the same size, so you can't use that as well. X those out. These are the four that we have learned so far. Here's a much more complicated proof than we've seen so far. Here's our diagram. We're given that ED is congruent to BC. That's ED here, BC here. Those are congruent. And BD is congruent to EC. There. That's it. So that looks kind of nice because CD is in common. We can prove this triangle here and this triangle here by side, side, side. Nice. Except they want us to prove AE is congruent to AB, this segment to this segment. How do we do that? So here's what you have to do. You have to go ahead and do what I said. First of all, get these two triangles by side, side, side. Then get the parts of those triangles to get these two triangles. Move from there to show AEC and ABD are congruent. And that way we can get AB and AE. Yikes. How do you do that step by step? That's the overall process. This helps in proofs to get the overall general picture. Here's what I know. This is where I want to get. How can I get there? So showing these two triangles using side, 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 then taking the parts of those angles and things in detail to get these two triangles, then I can use corresponding parts of congruent triangles are congruent. That's the overall. Now, how do I do that step by step? So let's walk through that step by step. Let's do the first part, showing these two are congruent by side, side, side. Okay, I listed the step one. I got the two sides from my given. I provided this third side using reflexive property. Now EDC is congruent to BCD by side, side, side. Okay, this next step is a little trickier to see. It might have been simpler if I had redrawn these triangles and separated them out. I didn't, mostly for space sakes, but I did draw an arrow. I know my goal is to get this triangle and this triangle, which means I need these two angles. The fact that these two triangles are congruent gives me this larger angle, EDC and BCD are congruent, but it also gives me this smaller angle here, BDC and DCE. It also gives me this right here. Gives me that and the bigger one. Now the reason I'm going to go ahead, those are corresponding parts of congruent triangles. I listed those because now I'm going to use that adjacent angles theorem that we talked about a while ago, and hopefully is still in your notes, which is basically this angle minus that. Because these big ones are congruent and these two are congruent, then adjacent angles, those two must also be congruent. That's going to give me the angles that I need for these two triangles. This one is tricky. So there's those two angles that I told you about, angle BDA, this one, and angle ECA, that one, because of the adjacent angles theorem. Also, these two triangles have angle A in common, so I'm going to list angle A. Now I've got these other triangles because I will have angle, angle, side, right? BD is already congruent to EC, and angle, angle, side. So let me list that. So I listed angle A is congruent to angle A by the reflexive property, which means triangle ABD is congruent to triangle AEC by angle, angle, side. And if I had room on the board, then I would finally write my proof statement. AE is congruent to AB because CPCTC, corresponding parts of congruent triangles, are congruent. Whew. All right, we're going to practice this. I'm just going to put some diagrams on the board. One at a time, we're going to look through them and we're going to determine, can we even find these triangles congruent? And if we can, which postulate or theorem will we use? So if we look at this one, can I say these two triangles with this information are congruent, yes or no? So we have two angles and a side. The side is corresponding, so the answer would be yes. We'd write yes, and we would use angle, angle, side. Angle, angle, side, because the side is not in between the two angles. Okay, here's another one. Can I show these two triangles are congruent? I have two sides, this side and this side, and I have an angle. The angle's not the included angle. It's not between the two sides. So I have side, side, angle, side, side, angle. Can I use side, side, angle? No, I cannot prove these two triangles are congruent. There is no side, side, angle congruence theorem. Another one, what do you think? I have all three sides, no angles. Is that enough? Yes, it is. Side, side, side. Another one, can I prove these two triangles are congruent? It looks like I only have two sides, so you might think no, because I only have two sides. But remember, vertical angles are always congruent. So even though it's not marked in the diagram, I know these two angles are congruent. So now can I? Ooh. Side angle side, side angle side. Yes, this is a side angle side. Another one, what about these two? They kind of overlap in the middle, so that makes it a little bit more confusing. But can I show those two triangles are congruent? I have these two angles and this side. Angle, side, angle. Yes, angle, side, angle will work. Okay, I hope that gives you a general idea about what this section is about, how to look at triangles, analyze what you know, can I prove them congruent with the information that I'm given, and if so, which postulate or theorem would I use? That's what this section is about. We're not done with triangle congruence because we have not talked about right triangles. We'll talk about that in the next section. But until we get to right triangles, go ahead and have fun with these, and I'll see you guys next time.